Good morning, students. In our last class, we have completed chapter set. Today, we are going to start with the new chapter. Okay, so let us just revise some of the number systems. Okay, the first set of number system which you did last time was the set of natural numbers, denoted by letter N. We are just revising the set of natural numbers. What are natural numbers? The counting numbers. So 1, when you count, you start your counting with 1. 1, 2, 3, 4, 5. How many are there? Infinite. Cannot be counted. So it's an infinite set. The next set of which we did was the set of whole numbers. Now in the set of whole numbers, how is it different from natural numbers? Only one number extra will be there. It is denoted by letter W and we have one extra 0. 0, 1, 2, 3, 4 and again it's an infinite set. Okay, the third set of numbers, I told you, you have to remember the number line. How is the number line? In the middle we have 0. In the right side we have positive, goes on and on, infinite, and in the left side negative. Again here it goes on and on, infinite, both the sides. So when you remember this number line, now it is easy to write the set of integers. Set of integers denoted by letter I, or you can denote it by letter Z. So which are the numbers? It's both sides infinite. So here I will write -4, -3, -2, -1, 0, 1, 2, 3, 4 and infinite both the sides. Okay, so natural number, whole numbers, integers are over. Then we have done rational numbers. Rational numbers, you all have studied it last year also and this year also we are studying it, denoted by letter Q. Q. Now we are going to write it in the set builder form. You all have studied sets, so you know how to write the set. Take any two numbers from the integer set. Let it be P and Q. If you write it as P upon Q, such that PQ belongs to the set of integers, only one condition is very important. Q should not be equal to 0. If Q is 0, you will get some number divided by 0. Division by 0 is meaningless. If I bring 0 chocolates and I say divide amongst yourself, isn't it meaningless? So division by 0 is meaningless. So that is why Q should not be 0. P and Q belongs, you take any two numbers from the set of integers. P can be 0. 0 upon something can be there. 0 upon 2, 0 upon 1, 2 upon 3, all those. So whenever you have something upon something, there is some number upon some number, it is a rational number. All integers are rational number. Why? Because if you take this number 4 upon 1, nothing is there, down means it is 1. So you can express it in P upon Q. So all integers are rational numbers. Now the next number system which we have not done is the biggest number system. We will be doing it in detail. Now let us just write down the set, this thing. I will write down the denotation first, what it is denoted by. It is denoted by letter R. R is equal to nothing but set of real numbers. What comes in this we are going to do in detail. But now you understand, real number is the universal set of all number system. What is the meaning of universal set? A grandfather set, the biggest system, number system in this universe. It will contain all these numbers, natural number, whole number, integer, rational number, everything is contained in this. So it will be the biggest number system. Okay. If you have in your bathroom, how do you keep your buckets one inside the other? Isn't it? The biggest one comes down and the other ones are going on inside it. till the smallest bucket. So same way, this is the biggest bucket you can see, the biggest universal set of all numbers. All other number systems are subsets of this. So you can say natural number is a subset of whole number, isn't it? Because all numbers are there, one extra number is there in whole number. So this is fully contained in this. So natural number is a subset of whole number. Now whole number is fully contained in this. See, you can see from here 0, 1, 2, 3, 4 is fully contained in this. So it's a subset of integers. And integers is a subset of, every integer is a rational number, already had explained. It's a subset of rational number. All these are the subsets of real numbers. So real number is the universal set. This is the universal set of all real numbers. Have you understood this? Okay, so real number is the universal set because all other sets are subsets of it. Please write this down in your notebook. Today we are going to study about this special system, that is the real number, the universal set. So I am going to write the topic, real numbers. Come on, write it down. Whenever you want to write down something, pause the video and write down. Okay, now we continue. Next we are going to concept you have already learned. Let us revise it. It is the decimal form of a rational number. Write this in your book, okay? Decimal form of a rational number. You all have already done how rational number is converted into decimal form. We are going to revise it by taking from the exercise. See, take practice set 2.1, sum number 2, the first one. 127 upon 200. Okay, let us do this, convert it into the decimal form. The other sums I am going to do, first I am doing this concept, so that is why I have taken this. 127 upon 200. So how will you do it? You will write down here 127 divided by 200. Now, you hide 7 and hide 2 zeros from here. 2 goes in 12 how many times? 6 times. So 200 into 6. First we'll write down 0.0000. Okay, let us write down this way. And now 200, does it go in 127? No. So 200 zeros are 0. 127. Put on the next number 0. Now what I told you do, hide 70, hide 2 zeros. 2 goes in 12 how many times? 6 times. So 200, there is a decimal point here, but after that you have put down 0. So whenever you are putting down 0, no, put the decimal point up. 200 6 are 1200. Minus it. Okay, now put down 1 0 from here down. Hide 2 zeros, hide 2 zeros. 2 goes in 7 how many times? 2 3s are. So 200 3s are 600. Put on the next 0. 200, you know how much it goes in? 1000. 5. So you get a remainder 0. So what is our first one? 127 upon 200. Final answer is equal to 0.635. It is a terminating. It is getting over. Okay. So it's a terminating decimal form. Okay. Now let us go to the next one. Second one. Second one is 25 upon 99. So again, let us write down 25.0000. I don't know how many zeros we'll need, divided by 99. Does 99 go in 25? No. 99 zeros are 0. 25. Put on the next number 0 here. But there is a decimal point here. Put the decimal point up. Okay. Now you hide here 0, hide 9 of this 99. So how much 9 goes in 25? 9 3s are 27, does not go. 9 2s are 18 goes. So 99 2s are. 2 9s are 18, carry 1. 2 9s are 18 plus 1, 198. Okay, let us take, this becomes 4 when you cancel this, and 10 minus 8, 2. 5. And 1 minus 1 is 0. Put on the next 0 over here. Okay. Hide 9, hide 0. How much 9 goes in 52? 9 6 are 54, does not go. So 6 times out of 5 are. So let us take 5. 5 9s are 45, carry 4. 5 9s are 45 plus 4, 49. Minus it, take 1 from here. This becomes 10 minus 5, 1. 1 minus 9 does not go. Reduce this. And 11 minus 9, 2. 4 minus 4, 0. Put on the next number, 250. But can you see here already you have got 250. So the numbers are going to repeat now after this, 250. What goes in 250? 198. That was 99 2s are 198. So you are going to get the same thing. You will get 10 minus 8, 2 and 5 and your 0 when you reduce this all. And here you are going to put down one more 2 and same thing is going to repeat again. 5s are 495 and again you will get 250 and so on. So this will go on and on. So what are you getting? 25 upon 99, your final answer 0.25 recurring. Isn't it recurring? 25, 25, 25 is going on getting repeated. So we put a recurring decimal. You all have studied it last year. So this is what type? This is non-terminating. The first one was getting over. That is called terminating decimal form. Now here this 0.25, 25, 25, 25 goes on and on. It is a non-terminating decimal form. Non-terminating means not ending. Okay. Whenever you want to write something, pause the video, write this down in your notebook. All this sum should be written. Third one, 23 upon 7. Let us do this. 23.0000 divided by 7. 7 goes in 23. Yes, 7 3s are 21. Put down 0, but there's a decimal point here, carry it up. 7 goes in 20, how many times? 7 2s are 14. How much you're getting? Put down the next 0. 7 8s are 56. Put down the next 0. 7 5s are 35. Put on the next 0. 7 7s are 49. Seven ones are 7. I am continuing it here. 10 minus 7 is 3. Okay. Put on the next 0. You can put any number of zeros after 23. So since it's not getting over, I am putting one more 0. 7 goes in this how many times? 7 4s are 28. Okay, here it is getting repeated now. 2 0. So now you will put this next 0, no? It becomes 7 2s are 14. And now it will go on repeating. 7 8s are 56. 4 7 5s are 35. So it will go on repeating after this it's going on repeating. Here, this is repeated. So we can write 23 upon 7 is equal to 3.285714. Then after that again 285714, 285714. This entire thing is getting repeated. So we put a bar on top. This is our answer. So what kind of decimal form is this? This is also not getting over. So non-terminating decimal form. Okay. Recurring also, same numbers are being repeated. So non-terminating recurring decimal. Write this down in your notebook. Now the next one is the fourth one. Not 17, 4 upon 5. Simple one. 4 upon 5. 4 divided by 5. 4 can be written as 4.00000 any type, any number. We don't know how many we need. 5 goes, okay, I think 5 goes in 4 how many times? It does not go. Put on the next 0. Put a decimal point. How much you're getting? 5 is a 40. Over this much only. So no need of these zeros. Okay. So what is 4 upon 5? Answer 4 upon 5 is 0.8. So this is terminating, getting over, terminating decimal form. Now there is one more sum, fifth one, that last let us do. I'll do that also. Fifth one is 17 upon 8. 17.0000, I don't know how many we need, divided by 8. 8 goes in 17? Yes. How many times? 2 times. 8 2s are 16. Put on the next 0. Put a decimal point on top. 8 goes in 10 how many times? 8 1s are 8. 2. Put on the next 0. 8 2s are 16. Put on the next 0. 8 5s are 40. You are getting remainder 0. You don't need of this 0 there. So that means it's 2.125. So write the answer. 17 upon 8 is equal to 0.125. You are getting remainder zeros. So this is terminating decimal form. It's getting over. Okay, 125. You are getting remainder 0. It's getting over. So 2.125 terminating decimal form. Okay, so all the sums of this is over. Question number 2, 1, 2, 3, 4, 5 we have done. Now let us classify them as terminating and non-terminating decimal forms. Okay. Okay, which was the first sum we did? 127 upon 200. 127 upon 200. Okay, and what was the answer we got? 127 upon 200. The answer we got was 0.635. I'll write out here a little this thing. 0.635. It was terminating. Okay, it was getting over. The next one, 25 upon 99. It was not getting over. 0.252525 was going on getting repeated. So where will it come? Here. 25 upon 99 is equal to 0.25 recurring. Next, 23 upon 7. 23 upon 7 also was non-terminating and recurring. That is 3.285714. It was recurring. We have done all these sums. Okay. So non-terminating decimal forms. We are classifying them as terminating and non-terminating. Now the fourth sum 4 upon 5 was getting over 0.8. 4 upon 5 was 0.8. And the last sum 17 upon 8 was also getting over 17 upon 8. This was also getting over. What was the answer? 2.125. Terminating. These are terminating, getting over. Final remainder 0 you get and gets over here. Here the remainder does not get 0. It goes on and on and on. So these are non-terminating decimal forms. So now let us see how they are. 127 upon 200. What are the factors of 200? 2 into 50 to 200. Let us see. 200. 2 into 100. 2 into 50. 2 into 25. And 5 into 5. And 5 ones are 5. So how many 2s? 2 into 2 into 2 into 5 into 5. Okay. So these are the factors. I'll tell you why I'm listing the factors, why I'm removing. 4 upon 5. What are the factors of the denominator? 5 into 1. 17 upon 8. What are the factors here? 2 into 2 into 2. I'm finding the factors of the denominator. Over here. Let me write this little that side. 0.25 recurring. Okay, here 99. What are the factors of 99? 99. 3 goes in this, no? 3 33s are, 3 11s are, and 11 ones are. 3 into 3 into 11. Okay, and this is a prime factor. 23 upon 7 into 1. What was the answer for this? So 23 upon 7. Was a big answer. 3.285714. This was non-terminating. Okay, now children, from this what can you conclude? Look at the terminating decimal forms and look at the non-terminating decimal. This was a terminating decimal. What are the factors over here? Can you see here? What is given here? 2 and 5. The only factors are 2 ka fact 3 times is there, 5 2 times is there. Over here, this is also terminating. What are the factors? 5 is there. And over here, this is also terminating. What are the factors? 2 is there. And over here, you cannot see any 2 or 5. This also does not have 2 or 5. This also does not have 2 or 5. So, we can conclude that whenever the denominator ka factors you remove and you are getting 2, only 2, only 5 or product of 2 and 5, then it is called terminating decimal form. Now, no need of dividing and find out whether it is terminating or non-terminating. You just look at the denominator, break them into factors and afterwards conclude if it's having only 2, only 5 or a product of 2 and 5, then we call them terminating decimal form. If it does not have in the denominator any 2 or 5, so other numbers it is having, okay, then it is called non-terminating decimal form. Okay. So what should it have for being terminating? Only 2, only 5 or a mixture of 2 and 5. If it's a mixture of 2 and some other number, then it will be non-terminating. Okay. So let me rub it. Please write down this in your notebook. So now I'm writing the method to recognize the terminating and non-terminating decimal form. Okay, steps to identify whether a given rational number is terminating or non-terminating. So how to identify? First, what you have to do? Find the prime factors of the denominator of a rational number. Second, if the prime factors, if these prime factors contain only 2 or only 5 or both 2 and 5. Then its decimal form is terminate. If the prime factors are other than 2 or 5, then its decimal form is non-terminate. Okay children, I have already explained to you how is to identify whether a given rational number terminating or non-terminating. You don't have to divide and find out. You can do shortcut method. What is a shortcut method? Find the prime factors of the denominator of that rational number. The denominator ka prime factors you find out. And if these prime factors contain only 2, only 5 or both 2 and 5, then its decimal form is terminating. If the prime factors are other than 2 or 5, then its decimal form is non-terminating. Write it down and study it by heart. Okay, now let us begin with practice set 2.1. The sum number 1. Classify the decimal form of the given rational numbers into terminating and non-terminating recurring type. Now I have given you the steps to identify. You don't have to divide and find whether it is terminating or non-terminating. Just a look into the denominator will help you to find out whether it is terminating and non-terminating. I have given you already the steps, so let us use those steps in solving this sum. 13 upon 5. Now 13 upon, what is it? First step is to find the prime factor of the denominator. Now this 5 into 1, no other factors. Okay, so now here we have in the denominator 5. Now I have given you in the steps that if the prime factors are only 2, only 5 or 2 and 5, then it is terminating. Decimal form is terminating. So here it is 5. Therefore this is a terminating decimal. Let us go to the next sum. Second one. 2 upon 11. 11 ka factors are 11 into 1 only. It does not contain 2, does not contain 5 nor 2 and 5 combination. So that means this is non-terminating type. So just by looking at the denominator, we are able to write down whether it is terminating and non-terminating. No need of dividing and find out. Third, 29 upon 16. Denominator can be broken up into factors. What are the factors of 16? 2 into 2 into 2 into 2. Now we have seen in the steps, if the denominator, if the prime factors are only 2, only 5 or a combination of 2 and 5. Now so here it is only 2. So that means this is terminating type. Fourth one, 17 upon 125. What are the factors of 125? 5 goes in this, 5 into 5 to the table, 5 into 5 into 5, 5 cube. So it is only 5. So therefore this is also terminating. Okay, so you have understood what you have to do first. Break the denominator into factors. After breaking the denominator into factors, just look. If the denominator contains only 2 or only 5 or a combination of 2 and 5, then it is terminating. Otherwise, it is non-terminating. One more sum left. One, 11 upon 6. Break the denominator into prime factors 2 into 3. But here it is not only 2, only 5 or a combination of 2 and 5. There is another number 3 which is coming. So that means this is not a terminating type. This is non-terminating. So students, please write down whatever is there in the video, everything you have to write it in the notebook and do the sums, practice at 2.1, 1 and 2. All the sums which I have done each and every sum, that you copy it in your notebook. And homework, problem set 2. Question number 1, third is of this type. Fourth also you can do. Question number 3. Or of this type. Write the following number in decimal form. 3 ka you can do 1, 2, 5. All the sums 3, 1, 2, 5. Third sum will be difficult. Third ka third root 5 it is given, that you leave. So I will write down 1, 2, 4 and 5. Third one you don't do. Homework. Okay, that's it students. Please do this homework. Problem set 2, first ka, third and fourth, and third ka 1, 2, 4 and 5. Remaining sums I will be doing in the class. Thank you.